At first glance, this device looks like an old radio station, but in fact, it is a navigation indicator of a spacecraft that played an important role in the history of Soviet crewed spaceflight, the Globus INK, at a time when computers were only just beginning to appear. The Soviet Union chose not software and code, but mechanics. The Globus INK had no processor and performed no calculations in the modern sense. Instead, it worked using electric motors, cam mechanisms, and a system of gears. Inside the device was a physical globe of the Earth rotating in sync with the spacecraft's flight. As the mission progressed, the instrument displayed the point on Earth where the spacecraft was located, as well as the direction of its movement. Based on its position, a cosmonaut could determine at any moment where the spacecraft was, above the planet's surface, the orbital path being followed, how many orbits had been completed, the geometry of deorbiting, and the expected landing area. The development of such instruments began in the late 1950 seconds. Early versions were used during the Vostok program, and the fully developed Globus INK became standard equipment on Voskhod and Soyuz spacecraft. The core idea was pragmatic. Even if onboard electronics failed, the cosmonauts still needed to see their position above the Earth, without calculations and without reference tables. The mechanical nature of the device provided key advantages. It was resistant to radiation, unaffected by electromagnetic interference, and operated predictably in the conditions of space. Yes, it was heavy and could not be reprogrammed, but this very simplicity is what ensured its reliability. The Globus INK was not installed as a separate unit somewhere inside the spacecraft, but directly into the instrument panel of the descent module within the cosmonaut's direct field of view. On Vostok, Voskhod, and early Soyuz spacecraft, the descent module had its own instrument panel with navigation indicators, and the Globus INK was part of that system. The instrument was mounted flush with the panel, like an aircraft indicator. From the outside, one could see a circular window with the globe, scales, needles, and switches. All the complex mechanics were hidden behind the panel inside the casing. This meant the cosmonaut did not see a computer, but a clear visual navigation indicator that could be consulted instantly, without calculations and without tables. That is why the Globus INK remained aboard Soyuz spacecraft for decades, even as digital systems became the norm. It is a reminder of a time when the path to space was built not with lines of code, but with precise mechanics and a rotating model of the Earth.